Hey, it's Miss Flores. So today we're going to be talking about dot plots. We're going to make some dot plots and we're going to analyze dot plots. So dot plots are basically a graph that shows the frequency of data along a number line. So it's basically like a frequency table, except for we show it on a number line. So let's look at our table. So it shows that Mia recorded the weight of each bag of apples people picked at an apple orchard. So first off, what we need to do is we need to order our numbers from least to greatest to figure out what our number line needs to look like. So first off, my least number would be 1. So I've got 1, and then I've got another one. You need to always write all of your numbers. So even if you got 1 twice, you need to write it twice. Then I've also got 1.5. I always cross my numbers out so that way I make sure to get rid of them that I've already counted them. Then I've got 2.5, 1, 2, 3, 4 times. So 2.5, another 2.5, another 2.5, and another, there we go, and a final 2.5. So I've got my 4 2.5s, and finally I've got 3 times. So 3, 3, 3, 3, 3, 3. All right, now we can draw our number line that includes all of our numbers on our list. So since we're going from 1 to 3, we could start at 1. Our number line starts at 0, but we need to make sure it goes all the way and includes all those numbers. So since we have our halves, I think we should count by half increments. So 0, half, 1, 1.5, 2, 2.5, and then 3. So that's going to include all of our numbers. Not every single number needs to have a dot above it, but you do need to have a number line that counts evenly and will include all of your data. And now, last but not least, we can put a dot above each number as many times as it occurs. So since 1 occurs twice, we can have 2 dots above 1. So we're going to have 1 dot and another dot. 1.5 occurs once, so we can have 1 dot above 1.5. 2.5 shows up 4 times. So we're going to have 4 dots above 2.5. And then 3 shows up 3 times, so we're going to have 3 dots above 3. And that is our dot plot. So as we can see, no bags of apples weighed 0, half, or 2 pounds, but they only weighed 1, 1.5, 2.5, or 3 pounds. 2.5 having the greatest frequency because it has the most dots above it. So that is how we create a dot plot. So let's look at some dot plots that we can analyze, some dot plots that are already made, and we're just going to answer some questions about them. All right, so members of a hiking club made a dot plot of the distances they hiked. What is the greatest distance that they hiked? What is the least distance? So the greatest number on the number line that has a dot above it is 9.5, right? 9.5 is going to be the greatest distance that anybody hiked. Just because 10 is on there, there are no dots above it, which means nobody hiked 10 kilometers. So that means the greatest distance that anybody hiked is going to be 9.5 kilometers. The least number that anybody hiked is going to be 7. So the least distance that anybody hiked would be 7 kilometers. The difference between the greatest and least numbers in a group is the range. So we can subtract them to find the range. So I would subtract my greatest, which is 9.5, minus my least, which is 7. Well, 9.5 minus 7 is going to be 2.5. So since the difference is 2.5 kilometers, the range is going to be 2.5 kilometers. So that's one thing you can answer when we're dealing with dot plots, is you can answer questions about range. Let's look at a couple more examples. So now, just like everything else, we can answer a multi-step question with dot plot as well. So it says a breakfast chef uses 3 different amounts of milk when making pancakes. Depending on the number of pancakes ordered, the dot plot shows customers' orders for pancakes one morning. How much milk does the chef need to make all the pancakes? Right? So let's look at our dot plot. We've got 2 dots above 1/4 cup, 4 dots above 1/2 cup, and 2 dots above 3/4 cup. So if I have 2 dots above 1/4, that means the chef has 2 orders they use 1/4 cup of milk. If there's 4 dots above 1/2, that means that there's 4 orders that need to use 1/2 cup of milk. And there's 2 dots above 3/4, which means that there's 2 orders that use 3/4 cup of milk. So if I need to figure out the amount of milk needed for those orders, I can multiply, right? We can do 1/4 times 2 to figure out how much those orders require. We can do 1/2 times 4 to figure out what those orders require. And we can do 3/4 times 2 to figure out what those orders require. So let's do the multiplication. Well, 1/4 times 2, that's going to be 1/4 times 2 over 1. Remember, anytime we're multiplying or dividing fractions, everything's got to be a fraction. So now I multiply numerators and denominators. 1 times 2 is 2. 4 times 1 is 4. So I end up with 4 with 2/4. We're going to leave it as 2/4 for now because we were wanting to find the total amount, right? So we can simplify later. All right. 1/2 times 4. So we're going to do 1 over 2 times 4 over 1. 1 times 4 is 4. 2 times 1 is 2. Since that's going to simplify to a whole number, let's do that. Well, that's going to be 4 2s. That's 2 groups of 2, right? So that's going to be 2 wholes. So we end up with 2 whole cups. And then 3/4 times 2, that's going to be 3/4 times 2 over 1. So we'll do 3 times 2, which is 6. 4 times 1, which is 4. That's improper. Let's just leave it right now. So we'll do 6/4. Now we've got to add them up to figure out the total, right? So I end up with, we can do 2 cups plus the 2/4 cup plus the 6/4 cup, right? Well, that's going to be 2 wholes and 8/4. But 8/4 can simplify to 2, right? Because I can get 2 groups of 4 out of 8. So that ends up being 2 whole cups plus 2 whole cups, which ends up being 4. So there ends up being, the chef needs 4 whole cups of milk to make all the pancakes. All right, let's use this dot plot, last but not least, to answer some questions. So now we've got another dot plot showing the ages of students in the science club. How many more students are 10 years old than 12 years old? So how many more? So each dot is going to represent a student and their age, right? So if we're looking at 10-year-olds and 12-year-olds, well, we have 1, 2, 3, 4, 5 students that are 12, and 1, 2, 3, 4, 5, 6, 7, 8 students that are 10. How many more? That's going to be 8 students minus 5 students. So 8 minus 5 is 3. So we've got 3 students that are 10-year-old students are going to have 3 more than the 12-year-old students. The same number of students are what 2 ages? Well, let's take a look. Well, we had the 5 12-year-olds, 8 10-year-olds, 11-year-olds have 1, 2, 3, 4, 5, 6 students, and then 8-year-olds have 1, 2, 3, 4, 5, 6 students as well. So the 8-year-olds and 11-year-olds have the same number of students. And what is the range of students? So what is the largest age minus the smallest age? That's 12-year-olds minus 8. So 12 minus 8, that's going to be 4. So there you have a range of 4 years between the oldest and youngest students.